we're going to be dealing with an exponential population growth function. In this case, we're going to work one where we have the New Zealand population in millions T years after 2010. So first off, it asks, what is the population in 2010? Well, a lot of information can be found from the function itself. So first off, the number that's in front of E will always indicate the starting number or the starting population. This number on top next to T, that'll be your growth or decay rate. In this case, would be your growth rate for the population. So when it asks what is the population of New Zealand in 2010, we'll look at the function and see it would be 36.8. In this case, that represents population in millions. Now the growth rate number is going to come from, again, the number on top. However, we usually write this as a percentage. So we'll take the number that we have, which is 0.008. We'll change that into a percentage, which means move the decimal point over 2 places, and this makes it into a 0.8%. Okay, so that's our growth rate. Now we're going to answer the question, what will the population be in 2020? So 2020 is 10 years past the starting year that we're looking at, 2010. So what we're going to use is the value of 10 for the value of t inside of our population growth function. So we're going to just basically plug that in for t. That'll look like A equals 36.8 e to the 0.008 times 10. Now I'm going to plug that in to the calculator to approximate what that's equal to. Then I press second, ln to get e, then 0.008 times 10, close parenthesis. Hitting enter gives me 39.8 or 39.9 if we round it to the nearest tenth. What will the population be in 2020? So that means that with the number we just got here, 39.9, will tell us the number in millions for the population in 2020. Okay, in a situation like this, what we're going to do is take our function and we're going to use the number of the population for the number for A. So we're going to use A equals 50 inside of our function. And what that'll look like is 50 equals 36.8 e to the 0.008 t. To solve for this, the first thing we need to do is divide out any numbers that are in front of e. So we're going to divide that to both sides. You can go ahead and plug the 50 divided by 36.8 into the calculator. Okay, so I got this number here. I'm going to round that up to about 3 digits. So I'm going to round that to 1.359. So on this side it would be 1.359 equals e to the 0.008 t. Now since that has an e, what we do to get rid of the e is we take the natural log of both sides. The natural log and e always cancel out with each other. So what we're going to have here is ln 1.359 equals 0.008 t. We can now divide out the number to both sides to solve for t. what we're going to have is t is equal to ln 1.359 all over 0.008. We can now plug this into the calculator, hit enter, and we'll get approximately 38.3. So that tells us the number of years, 38.3 years.